Hello viewers, I'm your instructor ZLE and you are watching the channel ZQ Tech. In this video we will discuss about the angle of the list calculation by using the formula for KMT. In the previous video we have found out KMT by using the graph curves of form. So if you haven't watched the previous video, watch that video first, then watch this video. So let's quickly start this video. Here you can see that the theta is the angle between the old center line and the new center line, as the ship is tilted towards the starboard side due to the consumption of fuel from the port side. So theta is the angle of list. So here are the steps to calculate theta. To calculate theta we have to find out tan theta, and for tan theta G0 G1 is find out by the previous formula you can see, while G0 MT is to be find out by using the formula KMT minus KG0. KG0 is given in the question, while KMT is to be find out. So here we will find out KMT by using its formula, not the graph curves of form. So here is the formula KB0 plus B0 MT. So here are some important distances before moving forward. This is the KMT, this is B0 MT, while this is KB0. And in this case we find out B0 MT by using Reed's Naval Architecture book for marine engineers. This book will give us B0 MT for any journal ship, while we will find out KB0 for any journal ship using the Simpsons rule. So quickly move forward. Bm is equal to I over del. We have discussed in the previous video, del is the displaced volume, while I is the second moment of water plane area about the center line of ship. So if we divide and multiply with tan theta, then what we will obtain? I tan theta is equal to V static G1. Or in other words, you can say that I tan theta is equal to V star G1. V is the volume of the wedge, while G1 is transfer shift in gravity of wedge. So you can visualize both of these terms V and G1 in the next section. So here is the container ship, and you can see that there is old water line and there is new water line, and this triangle is basically the wedge. If you look this picture in 2D, then this looks as an area. If you look this as in 3D, then it will look as a volume. So this is basically the wedge. This wedge is transferred towards the starboard side. So having the old wedge has the center of gravity G, while the new wedge has center of gravity G1. So this is the final result, that it is shifted towards the starboard side. And the distance between both of them is Gg1. Hope you visualize the V and Gg1 concept. So here is the water in which the hull of the ship is submerged. You can use the above formula, or you can use Bm is equal to I over del is equal to 2 over 3 y cube L over the displaced volume, where I is equal to 2 over 3 y cube L. This is I, or second moment of area for any journal ship, and we have evaluated this formula using the Reed's Naval Architecture book. So for now, for understanding the basics, we are not going into the evaluation of this formula. If you want to look into the detail of this formula, do read the Reed's Naval Architecture book. So using the Simpsons rule, KB is or KB0 is basically the vertical center of buoyancy. So its formula will be this. In it, del Z is the interval between the each water plane, while WP is the water plane area, and Zn is the distance from the keel to the specific water plane area. So in the next section you will clear these concepts. So here you can see that this is the water line, and this is the del Z, and it remains same for all the water planes, and these are the stations. These are the stations. while you can see that the Z1, Z2, Z3, Z4 are the distances from keel to the specific water plane area. And you will find out the interval del Z by using LPP divided by n minus 1, while n is the number of stations. So as we have 5 water plane areas, so this KB0 formula becomes up to the 5, where we will again use the formula for water plane area using the Simpson's rule. So this is the formula of water plane area, and this is for any nth water plane area formula. You are thinking about what is del x and what is y0, y1, y2, y3, and goes to n. So what are these things? We will discuss these things in the next section. Here consider that we are cutting the ship from its water line, which is at about the 16 foot, and what we will obtain this section. This is the water plane area. You are looking at the ship from the top. If you are looking at the ship from the top, take its half breadth. When you take its half breadth, then this type of graph is obtained. You can see that del x is the distance between the specific stations, while y0, y1, y2, y3, y4, these are basically the half breadths. FP and AP. FP is forward perpendicular, AP is aft perpendicular. So you can see that the stations are these 0, 1, 2, 3, 4, and half breadths are given. Y1, y0, y2, y3, y4. These are the half breadth distances given in the table. If you look at the half breadth at 0 station, it is not 0. Why it is not 0? Because we are taking the water plane at the 16 foot, and also that this is the red line, center line, and the side hull is not touching the center line, but it is touching indirectly in the form of vertical line, and this vertical line is 0.39 foot. So that's why we have not 0 value at the 0 station. So in the paper you have given the half breadth values, so don't need to worry about the half breadth values. And you can see that in the formula we have multiplied it with 2. Why we have multiplied? Because this is the half breadth. If we multiplied the formula with 2, then we obtained the full water plane area. Otherwise we will obtain only half breadth water plane area, which is not our requirement. So finally we get KB0, and hence we can calculate KMT, and after calculating KMT we can calculate G0 MT, and after calculating G0 MT, tan theta will be calculated. Hope you understand this video, and any queries comment below. Thanks for watching.